been basically modifying the carry chain so that you can balance the delay and reduce the overhead for carry. But from this point, we're going to look at the carry look-ahead adder, which means for each bit position, we can actually try to calculate the carry for that bit position with some kind of carry tree, complex carry tree. And this would definitely consume much more power than the adders you have seen, like carry bypass adder or carry select adder. But this is actually the fastest way to implement adders because you are actually looking at the carry chain for each bit, and then you can somehow guarantee that this carry calculation can be done in parallel fashion. Okay, so before we actually go through this carry look-ahead adder, let's revisit the concept of this PG and propagation, generation, and carry concepts. So let's say you have a n-bit adder where your input is A and B, and you have n-bit here. Then basically what we need to do is we need to calculate summation value for each bit position, right? And then to do that, and carry out, okay? And to do that, what we need is, for summation calculation, basically what you need is you want to calculate XOR of propagation of that bit, and then XOR of carry in for that bit. So for S0, carry in is whatever carry in you get. For S1, you need carry in coming from this first bit chunk. So that carry comes in, and then you have this propagation calculated from A and B. And if you keep go on, for the last bit, what you do is, again, you calculate the carry in from coming from the lower bit, and then you take the propagation value, which you can calculate from the AB value in that bit, and if you take XOR of that, that's the summation of that bit. So basically what this tells us is, if we can calculate the carry of each bit position, then that will let us calculate carry, summation value for each bit. So we need to figure out how this carry can efficiently calculate it and quickly calculate it. So to do that, we have to think about how this carry can be calculated, right? So we know that by using generation and propagation concepts, we can calculate these carries, okay? But there's some complex calculation involved with this. So let's look at this. From this point, we will introduce concept of G from a certain bit position to a certain bit position. Earlier, we only talked about, okay, G like 1 or G2, which is basically means for the bit position 1, bit 1 or bit 2 is generation condition met or is propagation condition met, something like that. But we want now, what we want to talk about is generation condition met for certain bit range, okay? So what that means is, if we have bit 0, 1, 2, 3, and we can think about, when we talked about one bit position, then on this bit position, then if A1 and B1 are both 1, then G1 generation condition for bit 1 is met, right? That's how we define generation or propagation condition for specific bit position, just one bit. But now what we can also say is, okay, maybe what about the generation condition for a certain range? Okay, so for example, for bit range 2 to 3, we will have carry out for bit 3, which will be fed into carry in of bit position 4, right? So for regarding this carry, we can also define some condition that, okay, for these bit positions, is carry generated or not? So let's say if we generate carry from this bit position 2 to 3, then regardless of the propagation condition for bit position 2 and 3, we can assume that, okay, we have carry in going into the next bit position. So we can think about this generation or propagation condition for certain bit range. Okay, so we are trying to expand this PG notation for range, not just one bit position. Okay, so that means that let's say if we talk about generation condition for bit position I to 0, so let's say 1 to 3, then basically this means is there carry in for bit position 4, right? If we generated carry for this range, then that will be forwarded to next stage, right? So basically G I to 0 means ith bits carry out or I plus 1th bits carry in. So carry generation for bit I to 0 range. Okay. How about propagation? So if we talk about propagation condition for one bit, then that means if there was a carry in for that bit, then there will be carry out for that bit. That's what we call propagation, right? But if we define this propagation for certain range, let's say for bit range from 3 to 2, then what can we tell about this? This means that if we have carry in for second lower bit position, and if this propagation condition is met, then this will propagate carry to fourth bit, not the third bit, right? Because this is propagation condition for range. You are propagating carry for certain bit range, not just for that bit. So this will result in carry in 4. Okay, so that means if we say, okay, propagation condition for ith bit to 0 bit, then that means it's simply propagation condition of each bit multiplied. So if every bit's propagation condition is met, then that means, okay, we have propagation condition for this bit range. Okay, so we're talking about propagation and generation condition for certain range. Okay, so now if we rewrite generation condition, now we can think about this mixture of generation and propagation. Okay, so if we say, okay, we want to check generation condition for ith bit to 0 bit 0, then what we can tell is, okay, let's say Gi, okay, let's say we have bit 3, 2, 1, 0, and we want to check G3 to 0. Okay, then what we can tell is G3 to 0 is actually either G3 or propagation condition of 3 and G2 to 0. So basically, if carry is generated here and propagation condition is met, then it will be forwarded, right? So that's this part. Or we simply generate carry on third bit, then for sure we will get carry generated. So we can rewrite it like this, right? So if we rewrite that in a more generic term, gi to 0 can be rewritten as gi plus pi and times gi minus 1 to 0. Okay? And then again, this gi minus 1 to 0 can be rewritten as gi minus 1 plus pi minus 1 times gi minus 2 to 0, like this. So if we expand this equation, what we can get is basically for third bit, if we generate, so if we talk about G3 to 0, we generate from third bit or propagate through third bit but generate from second bit, or propagate through P3, P2 and generate it from first bit, or propagate through 3, 2, 1 and generate from 0 bit. So if we add all these conditions, that's G3 to 0. Does that make sense? So basically each term represents that carry, if carry is generated from bit 0 and it's propagated through bit 0, 1, 2, 3, then it will be forwarded to next bit. Or if carry is generated on the first bit, then it should be propagated through second, third bit. Then it will be forwarded to next. Something like this. Okay, so it's a little bit, if you write this down, it looks a little bit complex, but what it tells is clear. Basically, we are writing the carry generation condition and dividing that into like different bit position and think about, okay, if we generate carry in certain lower bit position, what is the propagation condition meant for that case? So for easy example, this G2 to 0 is basically G2, P2, G1, P, yeah, something like this. Okay? So now,